Welcome to our deep dive into C programming. Today, we're exploring operators and expressions, the building blocks that allow your code to perform calculations, make decisions, and much more. Operators are special symbols that tell the computer to carry out specific mathematical or logical manipulations. Expressions, on the other hand, are combinations of variables, constants, and operators that evaluate to a single value. Understanding these concepts is essential for writing efficient and effective C programs. In this video, we'll break down each type of operator, use real-world analogies, and see how they work in code. Let's get started by looking at the different types of operators you'll encounter in C. Operators are like tools in a toolbox. Each one has a specific job, whether it's adding numbers, comparing values, or making decisions. In C programming, operators help us manipulate data and control the flow of our programs. Think of them as the action words in your code. They tell the computer exactly what to do with the information you provide. From simple arithmetic to complex logic, operators are everywhere in C. Let's explore the main categories of operators and see how they fit into your programming toolkit. First up are arithmetic operators. These are the most familiar, as they perform basic mathematical operations like addition, subtraction, multiplication, division, and modulus. In C, the symbols are plus for addition, for subtraction, for multiplication, for division, and percent for modulus, which gives the remainder. For example, if you write int sum equals a plus b, you're adding two numbers together. Arithmetic operators are essential for calculations, whether you're building a calculator app or processing data. Let's see how these work in practice. Next, we have relational operators. These are used to compare two values and determine the relationship between them. The main relational operators in C are equals equal to, equals not equal to, greater than, less than, greater or equal greater than or equal to, and less or equal less than or equal to. For example, a B checks if is greater than. These operators are crucial for making decisions in your code, such as checking if a user's input meets certain criteria. Let's look at how relational operators help your program make choices. Logical operators allow your program to combine multiple conditions and make more complex decisions. In C, the main logical operators are, and in logical AND, logical OR, and logical NOT. For instance, if you want to check if two conditions are true at the same time, you use AND. If either condition can be true, use. The operator reverses the result of a condition. Logical operators are like traffic signals for your code, directing the flow based on multiple factors. Let's see some examples of how logical operators work. Increment and decrement operators are shortcuts for increasing or decreasing a variable's value by 1. In C, ++ is used to increment and is used to decrement. For example, writing a ++ increases the value of a by 1. These operators are especially useful in loops, where you often need to count or repeat actions a certain number of times. They make your code cleaner and easier to read. Let's see how increment and decrement operators simplify repetitive tasks. Assignment operators are used to assign values to variables. The basic assignment operator is equals, but C also provides compound assignment operators like plus equals, asterisk equals, slash equals, and percent equals, which combine an operation with assignment. For example, a plus equals 5 adds 5 to a and stores the result back into these operators help you write concise and efficient code, especially when updating variable values repeatedly. Let's break down how assignment operators work and why they're so handy. Conditional or ternary operator is a compact way to write simple if-else statements. It uses the syntax condition, value of true, value of false. For example, int result equals a b assigns the greater of or b to result. This operator is perfect for situations where you need to choose between two values based on a condition, all in a single line of code. It keeps your code neat and readable. Let's see how the ternary operator works in practice. Now that we've covered the main types of operators, let's see how they come together in expressions. An expression is any valid combination of variables, constants, and operators that computes a value. For example, int sum equals a plus b is an arithmetic expression, while int check equals a b uses a relational operator. Expressions are the heart of your program's logic, allowing you to process data and make decisions. Let's look at more examples to see how expressions work in real code. Let's start with a simple arithmetic expression. Suppose we have int equals 5, b equals 3, int sum equals a plus b. Here, we declare two variables, a and b, and then use the plus operator to add them together, storing the result in sum. This is a straightforward example of how arithmetic operators are used in C. Such expressions are common in programs that need to perform calculations, from simple math to complex algorithms. Now, let's look at a relational expression. If we write int check equals a b, the expression a b compares the values of a and. If it is greater than b, the result is 1 true, otherwise it's 0 false. This kind of expression is essential for decision-making in your code, such as validating user input or controlling program flow. Relational expressions help your program respond to different situations. Logical expressions combine multiple conditions. For example, int logic equals a b, and in b0 checks if is greater than b and b is greater than 0. Both conditions must be true for the result to be 1 true. Logical expressions are powerful tools for building complex decision-making structures in your programs. They allow you to check several requirements at once, making your code more robust and flexible. Incrementing a variable is a common task in programming. In C, you can simply write a plus plus to increase the value of a by 1. This is much shorter than writing a equals a plus 1. Increment operators are especially useful in loops where you need to repeat actions a certain number of times. They help keep your code concise and easy to understand. Assignment operators make it easy to update variable values. For example, a plus equals 2 adds 2 to the current value of a and stores the result back in a. This is equivalent to writing a equals a plus 2. Using assignment operators saves time and reduces the chance of errors in your code. They're a staple in any programmer's toolkit. The ternary operator lets you write concise conditional statements. For example, int max equals a b. A b assigns the greater of or b to max. This is a quick way to choose between two values based on a condition, all in a single line. The ternary operator is perfect for simple decisions where you want to keep your code neat and readable. Operators are essential for making your programs do real work. They allow you to perform calculations, compare values, make decisions, and control the flow of your code. Without operators, your programs would be static and unresponsive. By mastering operators, you unlock the full power of C programming and can build more dynamic and interactive applications. In C, some operators are evaluated before others. This is called operator precedence. For example, multiplication and division are performed before addition and subtraction. Understanding precedence helps you predict how complex expressions will be evaluated. If you want to change the order, you can use parentheses to group parts of your expression. Let's see how operator precedence affects your code. Associativity determines the direction in which operators of the same precedence are evaluated. Most arithmetic operators in C are left associative, meaning they're evaluated from left to right. For example, in a BC, the subtraction happens from left to right. Some operators, like assignment, are right associative. Knowing associativity helps you write clear and predictable code. You can combine different operators in a single expression to perform complex calculations or checks. For example, int result equals a plus b c d slash e. Here, arithmetic operators are used together, and the order of operations is determined by precedence and associativity. Combining operators allows you to write powerful and flexible code that can handle a wide range of tasks. Think of arithmetic operators like the buttons on a calculator. When you press plus, asterisk, or slash, you're telling the calculator to perform a specific operation. In C, these operators work the same way, letting your program add, subtract, multiply, or divide values. This analogy helps you remember how arithmetic operators function in your code. Relational operators are like comparing two items to see which is bigger, smaller, or if they're the same. Imagine comparing the heights of two people. You might ask, is person A taller than person B? In C, you use relational operators to make these kinds of comparisons between values, helping your program make decisions based on data. Logical operators are like making decisions based on multiple conditions. For example, you might decide to go for a walk only if it's sunny and you have free time. In C, you use and for AND, for OR, and for not to combine or reverse conditions. This helps your program make smarter decisions, just like you do in daily life. Increment and decrement operators are like counting steps. Every time you take a step, you add one to your total. In C, using plus plus, or is just like counting up or down, making it easy to keep track of repetitions or progress in your program. Assignment operators are like putting items into boxes. When you assign a value to a variable, you're placing something into a container. Compound assignment operators let you add, subtract, or multiply the contents of the box before putting it back. This makes managing your data simple and organized. The ternary operator is like making a quick decision. Imagine you're choosing between tea and coffee based on what's available. If there's tea, you pick tea. Otherwise, you pick coffee. In C, the ternary operator lets you make these quick choices in a single line, streamlining your decision-making process. It's easy to mix up similar-looking operators like equals and equals equals. Remember, equals is for assignment, while equals equals checks for equality. Another common mistake is forgetting operator precedence, which can lead to unexpected results. Always use parentheses to clarify your intentions and avoid confusion in your code. Use operators effectively. Always keep operator precedence and associativity in mind. Use parentheses to make your code clear and avoid ambiguity. Practice writing expressions with different operators to get comfortable with their behavior. The more you use them, the more intuitive they'll become. Let's test your knowledge. Can you list all the arithmetic operators in C? Remember, these are the symbols used for basic math operations like addition, subtraction, multiplication, division, and modulus. Take a moment to recall them before we move on. Here's another quick quiz. What does the equals equals operator do in C? Think about how you use it in comparisons. It's important to distinguish it from the assignment operator, equals. Let's see if you remember the difference. Next question. Can you explain the difference between logical and logical or in C? Think about situations where both conditions must be true versus when only one needs to be true. Understanding this is key to writing effective conditional statements. How do you increment a variable by 1 in C? There's a special operator for this task that makes your code shorter and easier to read. Recall the syntax and think about where you might use it in your programs. Finally, try writing a simple expression using the ternary operator. Remember, it's a compact way to choose between two values based on a condition. Think of a scenario where you need to pick one value if a condition is true and another if it's false. Let's quickly recap what we've learned about expressions. Expressions are combinations of variables, constants, and operators that compute a value. They're the core of your program's logic, allowing you to process data and make decisions. Mastering expressions is key to becoming a skilled C programmer. We've covered the main types of operators in C: arithmetic, relational, logical, increment, decrement, assignment, and the ternary operator. Each serves a unique purpose and helps you write more powerful and flexible code. Understanding how and when to use each operator is essential for effective programming. When working with operators and expressions, always test your code with different values to ensure it behaves as expected. Use comments to explain complex expressions, and don't hesitate to use parentheses for clarity. Good coding habits make your programs easier to read and maintain. Operators and expressions are especially important in loops. For example, you might use an increment operator to count iterations, or logical operators to check multiple conditions. Mastering these tools helps you write efficient and effective loops that drive your program's logic. Conditional statements rely heavily on expressions. Whether you're using if-else or switch, you'll need to write expressions that evaluate to true or false. Operators help you build these expressions, allowing your program to make smart decisions based on data. Functions often use expressions to process input and return results. By combining operators, you can perform calculations, validate data, and control function behavior. Expressions make your functions more powerful and versatile. When working with arrays, you'll use expressions to access and manipulate elements. For example, ri equals ri plus 1 uses an arithmetic and assignment operator to update an array element. Mastering expressions helps you work efficiently with collections of data. In real-world projects, you'll use operators and expressions everywhere, from simple calculators to complex data processing applications. The more comfortable you are with these concepts, the more capable you'll be as a programmer. Practice writing and combining different expressions to build your skills. If your expressions aren't working as expected, use print statements to check the values of variables and the results of operations. Debugging helps you find and fix errors, ensuring your code runs smoothly. Don't be afraid to experiment and learn from mistakes. To sum up, operators and expressions are fundamental to C programming. They allow you to perform calculations, compare values, make decisions, and control your program's flow. By mastering these concepts, you'll be able to write more powerful and flexible code. Now that you understand operators and expressions, try writing your own code using different operators. Experiment with combining them in various ways to see how they interact. The more you practice, the more confident you'll become in using these essential tools. There are many resources available to help you practice operators and expressions in C online tutorials, coding challenges, and textbooks offer exercises and examples. Take advantage of these tools to reinforce your learning and build your programming skills. Congratulations on completing this overview of operators and expressions in C. These concepts are the foundation of all programming in C, and mastering them will open the door to more advanced topics. Keep practicing, stay curious, and you'll continue to grow as a programmer. Thanks for watching, and happy coding.